So to start, we're going to see how data is stored and structured in Data Hub. All sequential data within Data Hub is stored within streams. These streams are defined by their stream types, which act as a sort of blueprint to define what properties should be on the stream. Now, streams can be of various types. You can also have multiple streams per type, and these streams can then be contextualized using assets. Assets themselves do not contain any data, but they reference the underlying streams and provide a useful container for users to get a better understanding of what their streams represent. Additionally, assets can be based off of an asset type, though that is totally optional as they also do not require a type. So let's dig a little deeper and take a look at each of those components. We'll start with stream types, and these define how data is structured in a stream. They are immutable after creation, meaning you cannot change them after they've been created. They have properties, which are simple atomic types, ints, floats, etc., with optional units of measure. In this block, you can see that there are a few example properties. We have one for timestamp, which has an SDS type of datetime. We have another property, which is a value, and it has a double type. And lastly, we have quality, which is a nullable int 32 type. As you'll notice, none of these have units of measure, but that would be optional. Say we know that this value is always going to be a certain UOM, we can define that here. And as we'll see later, we could also define that on the created stream. Continuing on, types define how data is read from a stream. They have a key, which is the primary index that constitutes an ordered unique identity. In this case, we have the timestamp as our key. And types can be referenced by other types. Next, we'll take a look at streams. So streams reference a type. So we can see they have a type ID field. They can have tags and metadata, which are useful static information about the stream. Metadata is representing a key value pair. So in the case of sites, it might be SLTC in this case. And then tags, which are just a simple value, which could be something like pi to ADH. And these just give you an easier way to search your streams and find useful information about them. On our streams, we have the option to define secondary indexes, and we also can define property overrides that can be used to override units of measure or how data is read, for example, changing the interpolation mode of the stream. Next, we'll take a look at assets. Assets allow a user to model assets, equipment, or processes in Data Hub. Asset properties, so like the two we see here, reference streams and stream data. So in the case of this motor RPM property, we can see that it references the my first stream. And for motor temperature, we can see it references my second stream. So no data is duplicated. We're just referencing those underlying streams. Additionally, they have static information, which we call metadata. So this is very similar to our streams, where we have a key value pair. We can use the same example here, where we would have the site of the asset and the corresponding value. And as I mentioned before, assets can optionally reference an asset type, which we can see using this asset type ID. And lastly, I'll just quickly touch on asset types, and these are used to define assets of similar types. It's not a strict definition, as assets can have additional properties that are not on their asset type, which differs from the way stream types work. And the main benefit of asset types is that they are used for searching, as they can categorize your assets, and they're used for other features within our portal, along with other visualization tools. All the information in these slides came directly from docs.aveva.com. If I go to AVEVA Data Hub, we can see in our table of contents that we have a variety of sections for development. The sections that will be most useful are the developer guide and the API reference. If I take a look at the developer guide, we can see that there are sections for many of the features within AVEVA Data Hub, and under the API reference, we can get information about the specific routes, how to interact with them, and what they return. For example, if I go to Sequential Data Store and click Streams, we could see how to list our streams in our tenants, how to get a specific stream, what we need to put into our requests, what parameters we have available to us, what response we should expect back, along with the response body. Now that we've seen how data is stored and contextualized within Data Hub, let's go to the portal and see all of this in action. Okay, we're now in AVEVA Data Hub, where you can see I'm in the AVEVA Events namespace. So the first thing I'm going to do is I'm going to go to Data Management and click Sequential Data Store. And I'm going to switch to our types view. So we're going to review a few different types to start off with. I'm going to start off basic, so I'm going to search for the double type. And as you can see, I have this time index double type. If I click on it, we can see that this type is very simple. It only has two properties. So it has a timestamp property, which is a date time, and it has a value property, which is a double type. We can see the other base information here as well, such as its ID, its name, an optional description, along with an optional base type. Next, let's take a look at a little bit more complex of a type. So I'll search for air, and we can see that I have this air quality sensor type. And if I click on it, we've got 13 different properties here, so a lot more complex, and each of these corresponds with a different measurement type of the air quality sensor. Lastly, we'll take a look at another really common type, which is one of our pi types. So we can take a look at pi float 64. This is a type that is created automatically by the Pi to Data Hub agent to represent the data stored within our on-premises pi tags. We can see that this has a timestamp and a value, but it also has additional quality information such as its questionable flag, it's substituted, and so on. Information that you would expect to find on your pi tag. Great, so now that we've covered stream types, let's take a look at some of the streams defined by these. We'll start with the pi float 64, and if I click on the ellipses up in the top right and click Get Type Streams, we can see all of the different streams defined based off of that type. So just starting with the first one in the list, we can see that our stream has an ID, it has a name, and it has a reference type. Additionally, we have our static information such as metadata and tags. You see we have a tag, which is one of the projects that this is being used in, along with stream metadata, which are our key value pairs. So we have things like our engineering units, our point ID, really information that we got from the tag definition on our Pi system. And if I want to see data on the stream, I can do that just by clicking View Data. And we can see I'm looking at the last 100 events. Okay, now that we've looked at streams and types, let's go on to assets. So I'll go to Visualization and Asset Explorer, and we'll take a look at some of these wind turbine assets. I'll start with AE01 here. And on our asset, we could see that we have static information in the form of metadata. So this is a key value pair. And for each of these, we can also have a unit of measure. For our dynamic data, we have properties. And we can see that we have a whole list of different properties on this asset. And if I select some of these, we can take a look at them on the trend in the bottom. Additionally, assets can have an optional status. And so this is where we correspond one of those properties with the status of the asset. So for example, if one of those properties indicates whether our asset is in a good, warning, or bad state, we can map out those values and take a look at that information over time. In this case, I'm looking at the last 8 hours, but I could expand that to say the last 30 days. And we can see that there's some instances where this wind turbine has had some gearbox vibration issues. Going back to properties, Something I mentioned before is that assets don't actually contain data themselves, but they reference underlying streams. And if I click this Edit Asset icon, we can take a look and we can see in fact that these properties are referencing streams. One last notable feature of these Windtopia wind turbine assets is that they're based off of this asset type, which is GE wind turbine. If I select it, we can see that the list of expected properties for this asset are listed below, along with metadata. So when I create new instances of this wind turbine asset type, it'll have all of this metadata pre-filled out. I can modify what I need when I need it. And I can go through and map these properties to their corresponding streams. Likewise, I can define a status on this type, so that way all created assets of this type will also have this status mapping. Okay, and with that, that concludes our walkthrough of how sequential data is stored and contextualized within Data Hub.